I would like to make a wheel in this video. One of my first FreeCAD videos ever, I think my first FreeCAD video ever, I illustrated a way to make a wheel in FreeCAD that used lofting, whereas here I just want to use a simpler method, a little faster, a little easier. So let's get started by making a new part. And in the Part Design tab, I'll create a body, create a sketch, and if I orient, I'll have this be on the XZ plane. I'm going to start by creating a circle. We'll Shift R to give that a radius. Oh. We'll Shift R to give that a radius of 3.75. I'm going to create 4 more circles. Add a vertical relation with the V. Again, V, H, H. Well, that did not go. H. So now we have somewhat of a relationship between all of these. And now I'm going to select each circle. E for equal. We'll add a symmetric constraint to center it around. Oh, I clicked the wrong button. We'll add a symmetric constraint to center it on the origin. And now Shift V. We'll give that 4.5 inches. And H, 4.5 inches. So this will be a 4-lug, 117.3 millimeter wheel. This would fit on a classic 80s car. You can make whatever bolt pattern you'd like. And Shift R will give this a radius of 0.25 inches, so it'll be a 1/2 inch hole. We can close that. In fact, I can extrude that. And let's extrude that to 1/2 inch, right? Get a 1/2 inch mounting plate. The other thing that would be worthwhile to do is maybe adding a center hole, now that I look at this. So you can make this whatever dimension you want. I'm going to go with something like Shift R. Oh, let's go with 1.5 inch radius. And apparently it isn't centered on that line, so we'll simply merge those points. Now I can make another sketch. Let's make a sketch on the exact same plane, XZ. And I'm going to start making a spoke. To be concise and hopefully for repeatability, I'll cut on my sketch plane using this button and use the E key to make these equal. Select the 2 points of my arc and H to make them horizontal. And now I can choose a width with Shift H. Let's go with something like 3.5. We can always adjust that later if we don't like the way that it looks. And adding an arc, let's add a tangent relation. Shift R for radius, and we'll go with 1.5 inches. Again, we'll add a line and T for tangent. Now let's add a construction circle so we can reference where we want the spoke to end. Shift R for a radius, and let's go with a 9-inch radius. That'll put us in the ballpark of 18 inches. I'm not worried about exact dimensions, but this will be somewhat proportional to an 18-inch wheel. I'm going to add in another arc. I'm going to switch to 3-point. Excuse me. T for tangent and T for tangent. Shift R, and we'll give this 0.75 inches. Center point. H for horizontal. I'll drive this by angle. What angle do I want? We'll push A for angle. And relative to that vertical part, let's give this an angle of 170 degrees. And that fully constrains us. So all we have to do is match on the other side. Or, as I've said in some other videos, you can also give it the mirror entities. I find just replicating the sketch can be twice as fast after you re-add all of the constraints from the mirror function. So let's go with H for horizontal. We'll add in a line. We're going to say that these lines are equal length and these points are H for horizontal. And we'll add another 3-point arc, which we will say is equal, and we're fully constrained. So I'm going to close that. Let's go with an extrusion, and I'm going to say 4 inches on that. All right, so we extruded this 4 inches, and we can afford to make a polar pattern of our second pad. We'll make this 5 instances, and we're already around the correct axis. So now that we've done that, I'm going to make a sketch of the final profile of the rim section. I will not yet complete the final profile though. So on this, let's make a profile like this. T for tangent. We'll make this vertical, and Shift H for horizontal. So from our origin, this is going to be a 0 offset wheel. Let's go with 4 inches. That would maybe go a bit wider. 4.25 inches. That would give us an 8.5 inch wide wheel. That's kind of cool. Shift R for radius. Let's go with 0.375. Shift V. So the overall largest outer diameter we're going to have, let's say, at least the outer radius is going to be 8.25. No, because I've already got 9. So let's go 9.25. This is just, what dimension do you want your bead to go onto? I don't know what the standard is. I'm just going to say 9.5. And just like that. Not bad. I'm going to cut so that I can actually see my sketch. Shift V again for this profile. Let's make this 9 inches on the nose. Maybe a little bit further so we can get some engagement with that spoke. 9 or 8.85. That'll be pretty cool. Let's move inward for Shift H, probably 1/4 inch. I'm going to add in another radius. And to make this tangent, I can add a vertical relation. We'll make these E. Select this arc and this arc, E for equal. And we'll have the profile come in a little bit. A for angle. 30 degrees. If I do 45, that seems about right. Select these two, T for tangent. I've only got 1 degree of freedom, and that's going to be what length here. I'll add a 3-point arc. T for tangent. Make this vertical. E for equal. And again, 1 degree of freedom. V for vertical dimension. Let's say from there to there. 0.5 seems like a fine dimension. And then we'll continue on making some relatively arbitrary profile. How about 1.85? And then I'll come up in here. I'll choose this point for vertical, E for equal, E again for equal. I'll add a symmetric relation on those 3 points and make this vertical. And then the only question is what height do we want to go to. Again, I'm making an arbitrary wheel profile here. 0.15, how about? Shift H for horizontal. That's going to be 0.35, I guess. And then I'll replicate what we've done. This is asymmetric, like most wheels. Vertical. Equal. And choose these endpoints to be horizontal. Tangent. Vertical. Equal. Now I'll simply replicate this profile. Vertical. Equal. Horizontal. And then their only degree of freedom is this distance, which we'll get to. And you can constrain this however you want. It's all up to design intent. Horizontal. Equal. Make the most of my real estate here. I'm going to go with tangent. I'm going to go with equal, vertical, and that should be our only degree of freedom. I'm going to take a straight. E for equal. We're almost there until we get to the easy part. Vertical, equal, make that horizontal, and horizontal. And let's add an overall distance, Shift H. Actually, since I added this distance down here, 4.25, let's do the same. Again, that makes it 0 offset. And of course, we don't have a symmetric profile here like many wheels don't. So that ultimately gives us an 8.5-inch wide wheel. And the last thing that I'm going to do is offset this profile. So how thick do I want this to be? Shift H for 0.0625. Let's say that. And then I'm going to grab a center point arc. And I'm going to draw a bunch of arcs that I can constrain later. You'll notice these are inner and outer arcs, and yet they're all held equal. And so in a real design, you would want to make these have a consistent inner or consistent outer radius, which we didn't do here, but I don't think is a big deal. Okay, now all I have to do is use the line tool and add relations. Make that vertical. We'll make this vertical. We'll go horizontal with the H key. Make sure that this point is vertical. Took us a second to think. Make these parallel. Tangent with the T key. Tangent. Vertical. So we have 18 degrees of freedom, one of which is here, because we're not horizontal, so we'll make this point horizontal, and now the thickness remains consistent throughout the whole profile. I'm going to go vertical. 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 On here we'll want to add a tangent relation. We'll add a tangent relation over here. We'll make sure we are parallel. Tangent. Tangent. Vertical. Horizontal with the H key. Vertical, again V key for that. And horizontal, H key. And I should have used polyline, but there it is. Make that horizontal with the H key. Now, we've got 1 degree of freedom. Looks like I need to be vertical here. And we're fully constrained. So I'm going to close that, and before I do a revolve, to actually show the profile, I'm now going to make a sketch on the same plane. And that is going to be the YZ plane. Let's cut, and I'm going to edge import. This entire profile. And this will shape the spokes to the shape that we want to. So I do a simple trace operation. I shouldn't have to add any dimensions whatsoever because all these points are fully constrained, and so I just click and adhere to all fully constrained points. That should be every arc. Again, you can use polyline there. Horizontal. So let's close. I could have also traced this other outer profile as well. Let's do a subtractive groove, and we'll choose the Y axis. And OK. So there our spokes have the correct shape, and we're going to trim those spokes down a little bit further as we go along. Now I can do a additive revolve on the Y axis, and there's our wheel, so OK. And with that being done, now I can add some finishing touches onto these spokes. First thing, create a sketch, and again on the YZ plane, I'm going to choose what profile my sketch actually goes through. So here you can see we've got the spoke on this side. Oh, let me cut the sketch. Oh, I did. So I've got the spoke on this side. You can see that a little bit better. I don't like how it looks hollow right there, but you can see we're dealing with the spoke over here. So let's get normal to that view. Alright, first thing, let's go to the sketches. You can use the space bar to show the profile that I've sketched along. I can import from that sketch the edges that matter to me. And this will be a large guide in the shaping of these spokes. I don't think I'm going to use all these imported edges at the same time, but I will use most or all of them eventually. What I'm going to do first is choose an arc and make it coincident onto this arc. I saw that differently going in my head. I'm going to make an arc, 3-point. That's it. I'm going to make sure that these are horizontal with the H key. And I see the constraint, but I see that they're not horizontal. You give this a radius. How about, well, I meant to say 2. Yeah, looks like we're having some trouble with that arc, so instead I'm going to choose a center arc. Make sure that we're coincident. This is our center. It's going to be horizontal. That worked a little bit better. Don't know what was going on. I'm going to import another edge. This is the very top of my spoke, and I want this arc to meet the top of my spoke, so there's a vertical with the V key relation. I can stretch this arc out to be pretty much whatever size I feel is necessary. So I'm going to edge import the top of my mounting plate, or at least one point from the top of my mounting plate. Yeah, it doesn't. Oh, there you go. I'm going to add another arc. The end will be coincident. Again, I need to go back to 3-point. The end is going to be coincident and tangent. So we'll choose our line, T for tangent. There you go. Shift H, Shift V for vertical dimension. And we give this another diameter of 3.75. So you can see our arc starts right at the end of that mounting plane. That's what we want. And one last arc. We're going to use T for tangent. Tangent, Shift R, 3.75. Oh, let's go with 0.375 rather. And we can decide what profile that we want for the spoke going this way. So Shift R, 4.3, maybe 4.25, it's a nice even number. And then here, 5.4 perhaps. I'll choose polyline. This is going to again be horizontal. This will be vertical. There we go. So we're fully constrained. Let's exit. And I'm going to do a subtractive groove. It looks as though we've got a little bit of a problem. I'm going to specify the y-axis and see if these graphics work out. And they do. So that's what our wheel looks like so far. And sketching on the same plane. Let's cut our view and edge import here, 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 and here. Shift H for horizontal. I'm going to go below that tangent point, 0.25 inches. Let's go with the center point arc. Here. Let's go to these points here. Run a straight to be coincident to this line. And I didn't snap there, so let's grab that. Okay, merge these 2 points. We've got 1 degree of freedom. It looks like this endpoint didn't be coincident like I was hoping, so there we go, fully constrained. Now, come out this way. Shift V for vertical will do the same dimension, radius of 3.75. Of course, I keep clicking like it's a 3-point. Let's try that again. And go tangent. Let's do 2 arcs this time. Tangent. This is Joseph. And this looks like our center point here. So we're going to make sure that the center point is horizontal. And then I'm left to decide what radius values that I want. Shift R. Make this 1.125. And we have a closed profile. So I'm going to close here. Subtractive groove. And we're going to choose the y-axis. Okay. All right. We can probably add some finishing details. I'm going to start with chamfer. I'm going to go with something like 0.25 and add these holes as well. That's kind of a lot. 125 seems good. Okay. The other thing, we can finish off with some fillets if it will let us. I want to put a fillet right here. If FreeCAD can handle it, that's a really tricky fillet. Nope, so I think that's too complex of an edge for a fillet. Maybe right here. No, that's okay. We don't have to have fillets. So I think that's our wheel. Hope you've enjoyed this video. If it was helpful, please subscribe, and I'll see you in the next video.